We know that wearing a safety belt as part of the restraint system in vehicles can reduce our risk for injury in the event of an accident. But how do we know, and who tests them? On today's show, we'll hear from an expert at a crash lab in our community whose research has an important impact on the safety of people everywhere.
It really is rewarding to see manufacturers have that same concern and pick up our findings and say, I'm going to change my design. I'm going to change this safety system now that you showed me that. And so it's certainly satisfying to see improved safety designs as we get to newer and newer generations of vehicles.
We're going to the crash lab to find out how dummies make us safer and smarter. Inside this edition of CTSI Discovery Radio. Welcome to CTSI Discovery Radio. I'm your host, Brian Belmer. CTSI Discovery Radio is brought to you by the Clinical and Translational Science Institute of Southeast Wisconsin. The CTSI is a consortium of researchers, doctors, scientists, and others representing 8 institutions, including the Medical College of Wisconsin, Milwaukee School of Engineering, Marquette University, the University of Wisconsin-Milwaukee, Children's Hospital of Wisconsin, Froedtert Hospital, Blood Center of Wisconsin, and the Milwaukee VA Medical Center. The CTSI works collaboratively across all of our member institutions in advancing biomedical research and finding new drugs, treatments, therapeutics, and interventions that are better, faster, and more economical than ever. Our mission is advancing health through research and discovery. According to the National Highway Traffic Safety Administration, more Americans than ever understand the importance of wearing the seatbelts in their vehicles. In fact, the national use rate is now over 90%, which is great. However, that still leaves nearly 10% of our population that don't wear a seatbelt. Even in Wisconsin, where we have a primary enforcement seatbelt law, only 86% of people wear them, well below the national average. So, how real are the risks and consequences of not wearing a safety belt in our vehicles? We didn't have to travel far to find out from an expert. Dr. Frank Pintar is Chief of Research and Professor, Division of Research, Department of Neurosurgery at the Medical College of Wisconsin and Director of MCW's Vehicle Crash Worthiness Lab and Neurosurgery Research Facility. We had the opportunity to speak with him recently to learn about the impactful research he and his cohorts conduct at 2 state-of-the-art crash labs right here in our community. Research that is leading to innovations and improvements in increasing vehicle safety for all of us. Dr. Pintar begins by explaining that the Medical College's Vehicle Crash Worthiness Lab, or VCL, evolved from work that he and his cohort, Dr. Narayan Yoganandan, did with the National Highway Traffic Safety Administration.
VCL was open in 1997, largely the result of many years of working with the National Highway Traffic Safety Administration. We had been working with NHTSA on basic funding that they gave us for studying mostly head and spine injuries. The crash lab was really kind of a way to close the loop, understanding how our basic work in understanding human tolerance to injury translated to the final safety of a vehicle. And that's when Dr. Yoganandan and I proposed the new Vehicle Crash Laboratory.
So what was the primary goal in having the Vehicle Crash Worthiness Lab?
The specific need was to see how injury metrics really were finalized to find the safety of a vehicle. We had been giving those numbers for years, but we never really understood how they worked in the final assessment. And I think that was the impetus to understand, well, if this is what the manufacturers are going to use to design safer cars, maybe we can help them get an understanding of how it's used practically.
Working hand in hand with the VCL is the Neurosurgery Research Facility, or NRF, which opened in 2007. What's its primary function?
It's a laboratory that essentially simulates the deceleration of a vehicle crash, being able to put full-size dummies, but only part of the vehicle, the occupant part of the vehicle, on the sled. We had a sled lab in another building here on campus. The NRF was the upgrade to that.
Which means the NRF allows Dr. Pintar and his team to conduct and analyze crash tests at a whole different level.
Both labs are still occupant focused. The NRF in the sled facility, we can do a lot more measurements that we can't necessarily do in a full vehicle. But we can study it a lot easier in the sled, where we can still have the dummy experience the full deceleration, but measure a lot more things.
He says that while there are many crash labs across the country, labs like the ones in our community are rare.
Crash labs are either in manufacturing settings or in other private lab facilities. All the major manufacturers have them, and then there's probably 5 or 6 other independent labs that have them, and those are all for-profit labs. But we're one of only 2 that exist in academic settings. So along with the VCL and the NRF together, that is a very unique combination of laboratory space.
And while the medical college's 2 crash labs complement each other, they have their own unique features. We asked Dr. Pintar to describe some of the specific features of the VCL for full vehicle crashes. First, the crash track.
The crash is about 550 feet long, and the crash itself occurs inside a larger building where we are able to control post-crash movements of the car. The car is actually towed by a cable system that pulls the car down the track, and that car is then released right before impact, so it's free moving into whatever crash configuration we set it for.
Once a crash test is conducted, how is data acquired and measured?
We have a number of data acquisition systems that are collecting sensor information, whether it's chest deflection or shoulder deflection, forces and moments on the neck or in the spine. Those are the channels of information that we collect routinely. And all of those sensors are then used to help us define what the potential for injury to that occupant was in the crash.
What about the NRF, where the sled-type crashes are conducted? Dr. Pintar says among its notable features,
the big thing is the 3-dimensional camera capture system that we have as a permanent fixture. And this is a very unique camera system to study occupant movements in complex scenarios. And it uses similar kinds of camera system, but it tracks at very high speed. So obviously a crash occurs very quickly, on the order of 100 milliseconds. It's done. This camera system actually captures 3-dimensional movement at 1,000 frames per second, and that's what makes it a unique thing that we can only do in the sled environment.
How many crash tests are conducted each year at Dr. Pintar's crash labs?
We are mostly doing research tests right now. We are probably doing 12 to 15 crashes a year, so it's not that many, but these take quite a bit of time to actually get them done.
Exactly how long can a single crash test take to set up and conduct? Stick around. Dr. Pintar tells us in a bit. Ahead of that, what are different types of crash scenarios the full vehicle crash lab is designed to accommodate?
One of the simulations is a single vehicle goes off the road and slides into the tree, those kinds of very devastating crashes. We do what's called offset crashes, so only part of the vehicle is engaged, not the full front end of the vehicle. And we have what we call a flying floor. It's a whole platform that moves the car, and you can actually place the car in multiple configurations.
Dr. Pintar adds that his crash labs have become very skilled at studying the effects of some less common types of crashes to help improve driver and passenger safety.
We're doing crashes that we know little about, so it's easy to see it's a frontal impact, it's a side impact. But there's a whole series of crashes. Often you are traveling in an intersection, and if you don't make it all the way through or you misnavigate, you may get hit by the oncoming vehicle in that front corner. So is that a frontal impact or is that a side impact? It's not categorized well in our national databases. It's also not a crash configuration that is among the standards for occupant protection that the car manufacturers have to design for. This is what we like to look at, cases like that people haven't studied much before.
And the results of these crash tests have direct influence on the many safety features found in our vehicles today. Things like safety belt restraint systems, airbags, child car seats, and more.
Any of the occupant restraint systems we have influenced. When side airbags first came into existence, we looked at occupant protection with side airbags, and we looked at when a vehicle had a side airbag and it deployed in a way that might injure the occupant itself. And now, because we identified spleen injuries as a particular problem that may occur, we've seen in the most recent generation of side airbags actually have redesigned the way that those airbags look to not have as large of a volume right close to where the spleen is. those are the satisfying things that I know occur. We don't do the design itself, but we influence the design because of our research.
Next, Dr. Pintar tells us that the side impact crash tests that his labs conduct have contributed to something you've likely heard of: the National Highway Traffic Safety Administration's 5-star crash rating system for new car safety assessment.
It's consumer product information that we provided. We use the crash test itself for research purposes, but the funding comes as a government consumer information. So it's essentially the 5-star crash rating system. Our data from our lab is actually put on the web in safercar.gov. If you want to find out the relative safety of your car with respect to another one, or if you're buying a new car, you can look at the safety record in terms of 5-star ratings, and we added to that database of consumer information largely for side impact conditions. We've actually improved the 5-star rating and what goes into that actual rating.
If you want to see more about the 5-star crash rating system, that website again is safercar.gov. We'll post a link on our CTSI website along with this show. What other crash test studies has Dr. Pintar's labs conducted that have had significant influence on safety design for cars?
One of them is a very nice success. If you've heard of the Insurance Institute for Highway Safety, they do a number of car crash tests and then they release their safety ratings to the general public as consumer information. They have adopted a small overlap program. That new type of test is actually something that we identified. We said these are not well-studied crashes where the corner of the car is hit into a pole or another vehicle and it scrapes down the side, and there's an inordinate number of injuries that are part of that particular crash mode. They have now developed a standardized crash test for that, and vehicles now have to design against that crash test to get good scores. So we'd like to say we were the start of really identifying that particular crash as something to design for.
So far, we've talked about Dr. Pintar and his team's work on auto-related crash studies, but he says they collaborate with many other entities as well. For example, the Federal Aviation Administration.
The FAA has safety rules regarding belt use, and they have an actual research program to help improve safety standards for airplanes as well. Very little people might realize this, but many airplane crashes are survivable, and there's a survivable crash pulse that actually we can program now in the sled. So that's something advantageous for the sled, is I can simulate the deceleration that would occur in a survivable airplane crash.
He describes some of the specific crash tests he's done for the FAA.
FAA had standards for frontal occupant protection, so largely as you come down in an airplane, that's the only direction you're going is forward. But if you're seated where your seat is facing sideways during that crash, to you it's like a side impact, and so that's where they didn't have neck safety standards, and we helped them to develop them. Our grant that I just got renewed with the FAA now is looking at oblique impacts. If you've seen, a lot of the modern aircraft have 45-degree facing seats in many parts of the compartment. So that's another thing that they don't have any safety standards for. It's all for frontal or side now. So we're helping them develop safety standards for that oblique seating configuration.
And results from crash tests done for the FAA have resulted in improvements for safer air travel.
The FAA disseminates, obviously, that knowledge in the form of standards, and then different airplane manufacturers have to use those guidelines. But I have also heard in some smaller aircraft manufacturers, 2, 4, 6, 8 passenger smaller aircraft, like a Cessna would be an example, they have a little bit more flexibility to do some unique things like parachutes out the back, or even putting airbag systems inside the aircraft during a survivable crash and things like that. So we've influenced those kinds of safety features too in the smaller aircraft.
The VCL and NRF have also worked closely with the U.S. Veterans Administration.
We have had a grant with the Veterans Administration directly. That largely is to study brain injuries. We were looking at the difference between blast-related brain injury versus blunt trauma. A number of the veterans here are undergoing care for brain trauma, and we were looking more at basic science understanding of the difference between blast and blunt trauma.
Dr. Pintar tells us about one study hoping to better protect the men and women in our American military whose job it is to protect us.
Military programs that we have been funded for, and including now, it's one of our largest grants, is to look at military personnel in the field that are in their vehicles, examining specifically underbody vehicle blast. That's what we're looking at now. So it's another acceleration type vector, but but it's in a much different direction than in the automotive environment or the airplane environment, right? So you're looking at a vertical vector, and not surprisingly, the spine is also very much affected. The bottom of the vehicle is thrust upward very rapidly from the bomb. The vehicles are designed incredibly robust, so it's often intact, but the occupants are still thrust upward because of the bomb. And so we're actually helping to improve the safety of military personnel.
While the majority of Dr. Pintar's crash studies are funded by governmental entities, he says they do some work for private industry as well.
95% of our work is government funded in general. The work that we have done in industry is often to evaluate certain features that they are perhaps experimentally looking at and saying, does this particular belt system or combination of belt and airbag, will it perform well in this type of crash environment? So we have done some tests for the manufacturer in a particular crash mode that their new design of a safety system, they would like some initial results on.
Of course, the fact that the Vehicle Crash Worthiness Lab and Neurosurgery Research Facility are part of a medical college and independent doesn't hurt.
That helps as well, yes. So we're not just giving them the answers that they want to hear. We're not afraid of telling the truth and telling them that it may be a good design or maybe a bad design. And I think largely they come to us because of our medical connection, medical background. As I indicated before, there's very few of these types of facilities that have the medical connection to be able to know what kind of injuries can occur to the actual occupant.
And don't think these crash labs only do research for big government or big business. They also do some great work on a more local level. Dr. Pintar tells us about one study to help area emergency first responders.
Yeah, that's one of my favorite ones because these local firefighters are so passionate about doing their job well and being able to work with them as first responders. It's really a wonderful experience to be able to help them improve their techniques.
So how does this program involving local first responders work?
We actually partnered with a local nonprofit organization called Safe and Fast Extrication. They are a training organization made up largely of retired firefighters, training the current staff to do their occupant extrication faster and safer. And they teach a methodology that is really team-centered. And our role in that was to give them a realistic crash scenario. So we created a side impact, which was very challenging for them, that actually impinged the leg of the dummy in the vehicle. So they had to get out their tools and jaws of life and actually extricate that dummy occupant. The uniqueness was that we kept our instruments running for the head and neck, and we said, this occupant has a spinal cord injury, and you must treat them. So we gave them an idea of where in their lifting and moving extrication process that the dummy experienced the most head and neck movement, thereby helping them to improve their techniques for severely injured occupants.
He's happy to report two significant outcomes from this program.
We actually did a before and after crash. We took a car, we crashed it. Before they trained, they did their standard procedures. It actually took them almost an hour to get the occupants out. After the training, where they had a thorough understanding from the training group, it took them less than 20 minutes. So this was really great to see that just from the training, we could measure their progress. So that was the first outcome. The second outcome was to actually look at a spinal cord injured occupant where we could give them the actual sensor information of where their movements actually could have done some potential additional damage to a spinal cord injured patient.
We know the program is successful. Is it unique?
I don't know that anybody else is doing it. Talk to the firefighters as well. I mean, they're really ecstatic. As soon as I work with that other group, there's a lot of hands up that want to volunteer to do that because, again, they're passionate about what they do. They want to improve their safety measures. One of the things that we think is really fantastic about that program is as you get further out away from the city, a lot of them become volunteer fire departments and you don't have permanent full-time staff. So that ability to train new people coming in, now you've built a training regimen that the chief now can take on that training and say, here's how you do it. And they're not just trained on using tools, they're trained in the whole team approach.
Next, let's learn about the process for setting up, executing, and analyzing a crash test. First, we'll look at some of the technology utilized in recording various crashes in the VCL.
There is a lot of modern digital technology that we use to do these things. Years ago, when I first started this in the late 80s and 90s, we had film cameras. We used to have 16 millimeter film, and then we had to wait and get it developed and see if we did a good shot, and it was a big process. But now with digital camera photography, we can do 1,000 to 2,000 frames per second at higher resolutions, basically HD resolution. Those kinds of cameras are very expensive. Probably the cheapest one is in the range of $25,000. We have one that's even $100,000 that has very high speed, very high resolution. Other things like our 3D camera system, that's also very unique to capturing motion in a three-dimensional way.
How many cameras might be used in capturing a crash as part of a study?
Well, the 3D motion capture system, that's actually a 20-camera system. All those 20 cameras work together. But when we do the high-speed video cameras that are just one view, we often will have 5 to 10 different cameras running for different views. A vehicle crash, we will have closer to 10 because we want to track the vehicle motion, but we also have some cameras mounted in the vehicle to look at occupant motion. So there's often 3, 4, 5 cameras on board the vehicle that are recording occupant movement during the crash. That's really the important part for us, studying what the occupants are doing inside the vehicle.
Those occupants, of course, the crash test dummies. We'll hear more about them in a moment. But first, connected to those dummies are the sensors used to collect data from the crash. Dr. Pintar tells us about them.
A lot of accelerometers, so I can measure how much local acceleration occurs on that part of the dummy. Load cell information is basically measuring forces and torques. So if I want to know how much your spine bends or if you're under tension or compression in the spine, that's what a force gauge does. Sometimes it's measuring devices called potentiometers. So if the belt is pushing on the chest in an impact, I can measure that, how much chest deflection to the dummy.
Once data is collected from the sensors, where does that information from the crash go?
All of the sensors are plugged into that data acquisition board, and we like to have what we call a zero-time trigger, and then we collect after that. We always have redundant systems because we don't want to miss it, so we capture that into the data acquisition, and all that gets uploaded into our server that a lot of our engineers and other technicians can access afterwards, and then we do analysis.
While there are great systems for acquiring data, there's a lot to know about how to acquire data from a crash test.
Data acquisition systems, it's a whole actual course that is taught in the engineering school. You have to really have some strong engineering knowledge to be able to do that correctly. And those data acquisition systems are also very expensive, on the order of $150,000.
So now, let's hear about arguably the most important piece of equipment, the crash test dummies. Dr. Pintar says, just like people, they come in all shapes and sizes.
There's a whole family of crash test dummies. The classic one that you see is a 50th percentile male dummy, but there's a number of different dummies. This has been a lot of our work, is to help improve the human-like qualities and new generations of those crash test dummies.
Of course, they're not human, so they're not sensitive to being called dummies, but they are sensitive pieces of equipment.
We have a whole laboratory dedicated to just calibration of dummies, and all the calibration has to be done on a routine basis. The general rule is when a dummy has gone through 5 or 6 crashes of moderate severity, we do a whole calibration test again, so we know that the dummy is performing like it's supposed to. If the dummy doesn't, we often suspect a part that has been damaged in some way, and then we start replacing that part.
We've heard about the considerable cost of equipment used to record and capture crash data. What about the crash dummies?
Yeah, that's quite varied as well. The dummies that are less utilized right now, about $25,000. So that's about the minimum you would pay, and that's a dummy that has no instruments in it, no sensors. And then you start adding a sensor. So like a 6-axis load cell would cost about $15,000. So if you have 3 of those in there, all of a sudden you're up at $45,000. The newest dummies that are just coming out are on the order of $500,000.
Which is a lot of money, but it pales in comparison to the value of the human lives they help save annually.
When people see the dummies that go through that, we often see their eyes widening. Wow, does that really happen? And they usually ask, what was this crash speed? And I say, 30 miles per hour. What? So they don't have a good sense of the physics of a crash. If you're unbelted, all bets are off. You're traveling at 30 miles per hour relative to the vehicle, and you will keep going at 30 miles per hour unless you have a restraint system. So I can only tell you that a large majority of the people who die in car crashes are unbelted. The people that are belted, they have a much lower risk of dying in a car crash.
He adds that the amount of money spent on crash research is comparatively low.
For this kind of safety research, we spend actually very little money compared to things like cancer and cardiology. I mean, those are also important, don't get me wrong. But when you look at the cause of death, especially for the younger adult and child population, a very high cause of death is trauma. The message that the general public gets is that, oh, these are accidents. And I don't like that word accident because many of the times they are preventable. And so if you just brush it off as an accident, you won't want to spend money on it. In fighting disease, trauma is a disease. We have ways of preventing trauma. And we should also continue to do research in that area to improve lives.
Next, we asked Dr. Pintar to give us a perspective on how much time it takes to set up for a single crash test that will take mere seconds to conduct.
Even though the crash might only take a few seconds, the time beforehand and the time afterwards are really the majority of the time. It takes about a week of effort for our team, which is usually an engineer and multiple technicians. So it's about a week of time for them to get everything prepared. The vehicle, the dummies, the cameras, and the crash takes 10 seconds and it's done. Post-test, it's several weeks of analysis.
Given the considerable cost involved and the significant setup time, I'm guessing there's no margin for error.
Yes, the engineers that are usually in charge of these tests have so many checklists that they go through to make sure that everyone has done their job and everything is checked off, because you don't get a second chance. In fact, if you have a flaw in your test procedure, you will have to pay for the car to test it again. So as part of that grant, the government bought the first one, but if you mess it up, you have to buy the second one and test it at your own expense. It's very nerve-wracking.
Yes, it is. Even for as long as Dr. Pintar's been working in crash test research, which in his case is
going on 30 years now. I started with Department of Neurosurgery back in 1987, so this year is going to be 30 years.
And in that time, he's seen a lot of changes, especially in vehicle safety designs.
It's been satisfying over 30 years to see change in the vehicles, but I have seen this change drastically. The Insurance Institute for Highway Safety did a crash test between a 1959 Chevy and a 2009 Chevy. And when they crashed those two cars, the 2009 Chevy, the occupant in that vehicle probably walked away or had a minimum injury. The occupant in the 59 probably would have died. There's a lot of old-timers that would say they don't build cars like they used to. And I say, well, thank goodness they don't build cars like they used to, because nice, classic-looking car, but the safety improvements, it's just no contest.
He also recognizes that many consumers have come to know and expect better, safer vehicles.
People know that they are buying more airbags in their cars. There's more safety systems. There's so many more people that talk to me about buying their next car and saying, well, what's the safest car that I have in this price range? What kind of features should I look for? So the fact that this is on the forefront of their minds is really satisfying.
But while the vehicles we travel in are safer than ever, many people still run the risk of injury or even death by not wearing their seatbelts. For those people, Dr. Pintar has an expert opinion.
Use your safety system. Safety systems are there to protect you. Wear your seatbelt.
And he has a message for all drivers, because even the most sophisticated safety systems can't prevent crashes from happening in the first place, but we can.
You really need to concentrate on your driving. A lot of people are so confident in their safety systems that they think they can look at their phone or they can eat or they can do all sorts of things, but driving a vehicle is a complex task and it should take your full concentration. So don't let distractions get in the way. Pay attention to what you do.
Great advice. And with that, we need to put the brakes on this edition of CTSI Discovery Radio. Our sincere thanks to today's guest, Dr. Frank Pintar, Chief of Research and Professor, Division of Research, Department of Neurosurgery at the Medical College of Wisconsin, and Director of MCW's Vehicle Crash Worthiness Lab and Neurosurgery Research Facility. CTSI Discovery Radio airs the third Friday of every month. Join us for each episode. On behalf of the Clinical and Translational Science Institute of Southeast Wisconsin and all of our affiliate partners and members, I'm Brian Belmer, wishing you happy, healthy, and safer days ahead. For more information about research or to listen to this program online and on demand, please visit the Clinical and Translational Science Institute of Southeast Wisconsin website at ctsi.mcw.edu. And now, you'll find our podcast of this show in the Apple iTunes Store. Subscribe to CTSI Discovery Radio and you'll get each month's podcast automatically sent to your computer or mobile device. And remember, like us on Facebook and follow us on Twitter. CTSI Discovery Radio is written, produced, and hosted by Brian Belmer in collaboration with WMSE Radio. The CTSI and this program are under the direction of Dr. Reza Shakir.